Good morning, guys. I hope you are well. This is Mr. Ahmad bringing you another video on the process of electrolysis. It's found within chemical changes in the topic of the process of chemical changes. Okay, let's get into it. So in terms of this video, this is what we're going to cover. Describe which solutions allow electrolysis to take place, describe the movement of ions during electrolysis, and finally try and write some half equation reactions occurring at the electrodes during electrolysis. Now, in terms of all of this, what the aim is to understand the general idea of electrolysis, and we're going to dig deeper into the next few videos with specific examples. The first thing I want you to think about while the introduction plays is, why do you think we need to boil egg noodles before we use them to cook? So think about it. You've got, everyone's had instant noodles. Why is it that we are boiling these egg noodles before we cook them? You ready? Have a think. As always, guys, please remember to share the channel, and the social media is just there. So let's do some science. So the question I posed at the beginning of the video was, why do we need to boil instant noodles? Now, when we've got instant noodles, they're very hard. You can't really move them around. However, when you boil them, they're a lot more easier. They're easier to work with. Not a lot more easier. Doesn't make sense. They're easier to work with. You can put your masala in. You can put your spices in, whatever it is that you want to, and then move them around. And I want you to keep that that idea in your head while we talk about the next bit. Now, when we talk about electrolysis, we're talking about ionic bonding. So in ionic bonding, we've got a metal and a non-metal bonded together because there's been a transfer of electrons from the metal to the non-metal. So the metal becomes positive because it's lost electrons. If you lose negativity, you become more positive. And the non-metal has gained electrons. So if you gain electrons, if you gain negative charges, you become more negative. Okay. So if you actually take a step back and look at the entire molecule, then what you've got is this giant lattice structure where all the atoms are held together very, very strongly with these with electrostatic forces. Okay. And if I was to try and break these ions apart, so if we, I don't know, said the red circles were the metal ions, so they're positive, and the green circles are the non-metal ions, so they're negative. If I was to try and break them apart, I can't really move them. So yes, we've got charged particles, but they don't conduct electricity in any way because they can't move. However, there's two ways that we can get them to move. We can either melt the entire thing. So in other words, we increase the temperature so much that the electrostatic forces that are holding them together break apart and the ions can move around freely, and that's when you've got a liquid. And the other way that we can do them with ionic compounds is we can dissolve them in a liquid. And when we dissolve them in a liquid, or when they are dissolved, then again the ions break apart, and the water is really interesting like that. The ions break apart and they can move around freely. Okay, so when ionic compound is melted or dissolved in water, the ions are free to move about within the liquid or the solution. Now that's a really, really key part of understanding electrolysis and how it works. These liquids and solutions are able to conduct electricity and are called electrolytes. So often you hear electrolytes being referred to in sports drinks and stuff like that. All that means is there's charged particles, charged sodium, whatever it might be, that is in the drink, which helps to rehydrate you. Okay, so you can actually get these charges to move around, but there's a few extra pieces of equipment that you'll need for electrolysis to take place. First thing you need is a vessel. Okay, so I'm just going to label that V for vessel. It can be anything from a beaker to a plastic container, whatever you want it to be. You also need a power source. Now, when we talk about this is from physics, but when we talk about a power source, or when we're talking about a power supply with a circuit symbol, this circuit symbol represents the positive and the shorter one represents the negative. And that's really important when we talk about the next bit. So the next bit is having electrodes. Now, the electrodes are actually inside your liquid. And again, because the electrode on your left is connected to the positive terminal, this electrode will be positive, okay? And the electrode on your right will be the negative electrode. And that's, again, really important when you think about electrons. So if you've got a power supply hooked up to these two electrodes, then actually you've got a build-up of negative charge on the electrode on the left, and a lack of positive charge, or rather a lack of electrons on the left-hand side. You finally then need your solution with your ions in them that have been dissolved. So in this example, so if we say sodium chloride and water, then I've got my ions that now are in the water. So what does all of that mean? Well, basically, passing electric current through electrolytes causes ions to move to the electrodes. Positively charged ions will move to the negative because opposites attract, and hence the negative charged ions will move to the positive because opposites attract. Okay, now notice what I've said here. So the negative electrode is called the cathode, so this one here is called the cathode, and the electrode which is positive is called the anode. So the negative electrode is called the cathode and the positive electrode is called the anode. The cathode has an excess number of electrons on it, and the anode doesn't. Okay. Now, how does this work? Well, basically, once you've put your electrodes into your electrolyte solution, you've got a situation where the ions are going to move. So where are they going to move? Well, we just said the negative ion is going to move towards the positive electrode. Which one's that one again? Well, it's this one because it's connected to the positive terminal. And this one's a negative one, and that's connected to the negative terminal. So let's start with, let's start with positive first. So the positive ion will move towards a negative electrode, and once it gets there, it will gain electrons, and therefore it will no longer be an ion, it will just be a metal atom. So again, the positive ion will gain electrons and become a metal ion. The negative will do the same but in the opposite direction. So the negative will move to the left because that's where the positive anode is, and it will once it's there, it will lose the excess electrons that it's got that's made it an ion, and it will turn into a non-metal atom. Again, it will lose electrons and it will become a non-metal ion. That, bear in mind, I've said gain and lose a lot. I've kind of really stressed them. The reason I've stressed them is because that's going to come up later in the video. Now, in terms of this setup, so what did we say? What was the summary? Ions are discharged at the electrodes producing elements. So what do we mean by discharged? So that means they no longer are charged. If they're no longer charged, then that means they've either gained or lost electrons depending on what they are. Finally, this whole thing is called electrolysis. So a quick kind of recap again is the positive ion will gain electrons. So I'm just going to write G. Will gain electrons, and the negative ion will lose electrons. So if you've gained electrons, you are going to become neutral, and that's going to become a metal ion again, and the negative ion will lose electrons and again become a non-metal atom. So up until now, everything that we've gone through, you need to know whether you're doing the foundation tier or the higher tier. However, the next bit is only for the students that are doing the higher tier paper. So let's look at this. One of the things that higher tier students will need to be able to do is write half equations that are happening, particularly with electrolysis, at each electrode. Now, the example I'm going to use is using aluminium. Now, I've got an aluminium 3 plus ion and the negative electrode there. How do I know it's a negative electrode? Well, it's got these tiny blue electron or things that represent the electrons in the cathode. What's going to happen is the aluminium ion will gain 3 electrons. So it will gain 1, 2, 3 electrons. And why does it do that? Well, it's got a charge of +3, so it lost 3 electrons when it became an ion. Now, why do I keep using the words gain and lose? Because they refer to specific processes. Reduction is the word that I wanted to start using, is the gaining of electrons. So what's happening? I've got an aluminium 3 plus ion which has gained 3 electrons, and therefore it has been reduced and becomes an aluminium atom. Okay. At the opposite electrode, you've got the opposite thing happening. Well, what's that? So, and I cheated it slightly, and I'll explain why in a second. Oxygen ions will lose 2 electrons. Now, I've drawn them separately, but you aren't able to tell which electrons have been gained by the oxygen atom. But I've done it for animation purposes. So what's happening is your oxygen ion arrives at the positive electrode, and it will start to lose these 2 electrons that it has an excess of. And oxidation is the word that we use to describe losing an electron. So it was reduction describes gaining an electron. Oxidation describes losing an electron. So what's happening here? Well, I've got O minus 2 becomes an oxygen atom plus 2 electrons. Okay, but that equation isn't balanced because actually what I've done is I need 2 of these oxygen molecules. Let me change my pen color. I need 2 of these oxygen atoms to make an oxygen molecule. So actually what I need is 2 oxygen ions, which will form O2, and it will actually produce 4 electrons in excess. Okay, so that's just me balancing the equation. However, in terms of the actual half equations, again, like I said, it's something that you need to be able to know and be able to practice. We're going to do that over the next few videos, so don't worry too much about it. Now, the last thing I want to leave you guys with is those 2 words, oxidation and reduction. So what do I mean? And the way to remember that, which one's which one's losing electrons, which one's gaining electrons, is the word oil rig. So oil rig is a quick way to say oxidation is losing, reduction is gaining. Okay, so that's a quick and easy way, and it's a very common way of remembering which one is which. Okay, so guys, as always, thank you very much for watching. Share the channel, like, subscribe, all those things, and follow on the social media channels. Take care, look after yourselves, be safe, bye.